a desert that turns into a mirror 129 kilometers across. An island cut off from the rest of life on Earth for 20 million years, producing trees that look like alien spacecraft and bleed red. A cave in New Zealand where thousands of tiny carnivorous creatures hang from the ceiling on silk threads and glow blue-green in the darkness, creating an underground galaxy that has been shining before any human being set foot on the island. A lake in Venezuela where lightning strikes up to 280 times per hour, every hour, for 9 hours per night, on 160 nights per year, the same location, the same time, reliably for as long as anyone can remember, producing more lightning annually than anywhere else on the surface of the planet. And a desert that has been dry for 55 million years, older than every mountain range in Europe, older than most of the continents in their current configuration, sustained by a single source of water that arrives not as rain, but as fog rolling in off the Atlantic Ocean before dawn. These places exist, all of them, on the same planet you live on. Most people will never see any of them, and many people do not know they exist at all. This is Shadow Atlas. If you are new here, hit subscribe. I cover places like this every few weeks, and the list of things this planet contains that most people have never heard of is genuinely inexhaustible. Let's go. In the southwestern corner of Bolivia, at an elevation of 3,656 meters above sea level, higher than any peak in the Alps, there is a flat expanse of white that covers 10,582 square kilometers. That is the size of Jamaica, or slightly larger than the state of Connecticut, and it is entirely flat. Not approximately flat, not mostly flat. The entire 10,582 square kilometers vary in elevation by less than 1 meter. The flatness is so extreme and so consistent that NASA uses it to calibrate the altimeters of Earth observation satellites. The ocean is too dynamic, too variable to serve as a reliable reference. The Salar de Uyuni is more reliably flat than the sea. The Salar de Uyuni is the largest salt flat on Earth. It formed from the evaporation of prehistoric lakes that covered much of southwestern Bolivia during and after the last ice age. As the water evaporated, it left behind what it contained, salt principally, but also a concentration of other minerals that the water had dissolved over thousands of years of geological contact. The salt crust that remains is up to 10 meters thick in the center. Underneath it, saturating the porous substrate, is a brine, a highly concentrated saline solution that holds in dissolved form the single largest known deposit of lithium in the world. The estimate varies by methodology and by the year of the assessment. But the Salar de Uyuni contains somewhere between 50 and 70% of all known lithium reserves on Earth. Lithium powers the batteries in every electric vehicle, every laptop, every smartphone. Clean, consistent, regular hexagons, tessellating across thousands of square kilometers of flat white surface, each one bordered by a low ridge of salt and each one slightly concave at the center. From above, the Salar in dry season looks like it has been tiled by an engineer with unlimited time and perfect precision. The hexagons run to the horizon in every direction. In the wet season, from December to April, the story changes entirely. Rainfall in the Bolivian highlands flows down from the surrounding mountains and across the flat surface of the Salar, and because the surface is so extremely flat, the water does not drain. It stays. A thin layer, usually a few centimeters, rarely more than half a meter, spreads across the white salt. And on a windless day, in the first light or the last light, or under a clear sky at night, what happens is genuinely difficult to describe to someone who has not seen it. Following rain, a thin layer of dead, calm water transforms the flat into the world's largest mirror, 129 kilometers across. Not a mirror in the approximate sense of a reflection in a lake. A mirror in the complete sense, a surface so flat, the water layer so thin and still that the boundary between the surface and the sky above it dissolves entirely. There is no horizon. There is no visual distinction between where the ground ends and where the sky begins. The clouds are above you and below you simultaneously. The mountains at the edge of the flat appear to float in midair, their reflections hanging beneath them with equal precision. In photographs of this phenomenon, long exposure shots taken at golden hour when the light is at its most saturated, the results consistently look more like composite images, digitally manipulated, than photographs of the real world. On clear, rainy season nights, the water mirror reflects the Milky Way so perfectly it feels like stars are above and below you. The high altitude of the Salar, 3,600 meters, well above the light pollution of most of Bolivia, means the night sky above it is already extraordinary. With the reflective surface of the wet salt flat below you, you are surrounded on all sides by stars. The visual boundary between the terrestrial and the celestial is gone. Photographers who have shot this describe lying flat on the salt surface in the darkness with the reflection of the Milky Way inches below their faces and the actual Milky Way filling the sky above, and the feeling of floating in space. In the center of the flat, unreachable during wet season without a boat, rising from the white like a hallucination, is an island. Isla Incahuasi, sometimes called Isla del Pescado. The island of the fish, for its shape when seen from above, is a former volcano. A rocky outcrops covered in columns of cactus that rise to 10 meters. Some over 1,200 years old, providing a stark contrast to the surrounding white. Cacti that began growing in the same century that the Vikings were colonizing Greenland, standing in the center of the world's largest salt flat, surrounded by a mirror of sky. Nothing about it is in the correct relationship to anything else. The scale, the color, the age of the plants against the whiteness of the surface. It produces the specific visual confusion of a landscape that refuses to resolve into normal spatial logic. The flamingos make it stranger still. 3 species breed on the Salar and in the surrounding high-altitude lagoons: the James's flamingo, the Andean flamingo, and the Chilean flamingo. Their pink feathers derived from the pigment in the brine shrimp they filter from the salt lakes. Pink flamingos on a white mirror at 3,600 meters, next to a 1,200-year-old cactus island, under a sky that is also underfoot. The Aymara people of the Bolivian highlands have an origin legend for the Salar. The mountains surrounding it were once giants, and one of them, named Tunupa, cried so hard when her husband left her that her tears, mixing with her milk, formed the flat. The name Tunupa refers to the volcano at the northern edge of the Salar, which the Aymara consider sacred. The legend is an origin story for a place that even people who live next to it recognized as requiring an extraordinary explanation. There is an island in the Arabian Sea that broke away from the African continent approximately 20 million years ago. The separation happened slowly as tectonic forces pulled the landmass that would become the Arabian Peninsula away from Africa, and the island caught in the process, positioned at the entrance to the Gulf of Aden, between the Somali coast and the southern Arabian coastline, eventually became isolated by open water. Separated from the African mainland for at least 6 million years, and from the Arabian Peninsula for perhaps 20 million years, it has produced a landscape and biota unlike anything else on the planet. The island is called Socotra. It belongs to Yemen. Though it sits 240 kilometers from the Horn of Africa and 350 kilometers south of the Arabian Peninsula, physically closer to Somalia than to the country that governs it, it covers approximately 3,625 square kilometers, roughly the size of Rhode Island, and it holds in its extraordinary isolation a biological inventory that has been evolving independently for longer than most of the world's mountain ranges have existed. Of the 825 plant species found on Socotra today, 307, 37%, are endemic, meaning they live nowhere else. 90% of its reptile species are endemic. 95% of its land snail species are endemic. These numbers are not produced by unusual conditions that happen to create unusual organisms. They are produced by the simple fact of time and isolation. When a landmass separates from the continental body it once connected to, the life on it begins a separate evolutionary journey. Given enough time, and 20 million years is a very long time, that journey produces results that could not have been predicted from the starting point. The life that exists on Socotra today is the result of 20 million years of evolution operating in an isolated laboratory, without input from the mainland producing solutions to Socotra's specific challenges that no other place needed to produce. The most famous result is the dragon blood tree, Dracana cinnabari. It exists only on Socotra, and no photograph adequately prepares you for the experience of seeing a forest of them on the Dixam Plateau. The tree grows slowly at approximately 2 to 3 centimeters per year to a height that eventually reaches 10 meters. Its trunk is thick and gray. Its branches divide repeatedly as they grow, each division producing 2 new branches, the whole structure becoming increasingly complex from the base upward. And at the final level of division, the branches do not grow further outward or upward. They stop, and the leaves grow densely there, and the cumulative effect of all those final branches is a canopy that is flat across the top and densely packed. An enormous, near-perfect circle, like an umbrella, like a mushroom, like nothing that grows anywhere else on Earth. The shape is functional, not aesthetic. On Socotra's dry plateau, rainfall is scarce and unpredictable. But mist comes. The monsoon that makes the island inaccessible by sea from June to September also brings moisture that rolls across the high ground in dense fog. The flat canopy of the dragon blood tree is designed to catch this moisture, to intercept the fog particles as they pass through the dense mat of leaves, to collect them, and to channel them down the branches and trunk to the base of the tree, where the roots absorb them. The tree drinks the fog. Its shape is a water collection system of extraordinary efficiency, evolved over millions of years of dry seasons on an isolated island plateau. The dense canopy provides shade that helps reduce evaporation from the rocky, arid ground beneath, creating a microhabitat that supports other plant and animal life. And when you cut the bark, the tree bleeds. The resin that flows from any wound in the wood is a deep, saturated crimson. Not reddish-brown, not orange-red, but the specific color of fresh arterial blood. This is dragon's blood. The ancient Egyptians knew it. The Romans used it as a dye and as a theatrical prop for staged battles. Arab traders carried it along the incense routes of the ancient world. Medieval European artists used it as a paint pigment. It has been applied as a medicine, a preservative for string instruments, an incense, and a lipstick on Socotra itself, where the resin is called Dam al-Akawain, the blood of the two brothers, after a local legend that the first tree grew where two brothers fought to the death. Socotra also has bottle trees, Adenium socotranum, whose swollen, bottle-shaped trunks, wide at the base and tapering sharply upward, jut from cliff faces at impossible angles, storing water in their bark for the long dry months. It has the only species of cucumber that grows as a tree. It has a species of frankincense specific to the island. It has endemic birds and reptiles and insects that exist in no reference collection from anywhere else on Earth. The Italian explorer Niccolò de Conti described Socotra in the 15th century as the source of the dragon's blood that was traded throughout the known world. The ancient Egyptians imported its aloes. The island has been known to the outside world for as long as the outside world has had maritime trade in the Indian Ocean. And yet, it looks to anyone who arrives from any other landscape on Earth completely alien. Not alien in the casual sense of the word. Alien in the literal sense. A place that appears to belong to a different planet's biology. A place that evolution has taken somewhere so far from the starting point that the results no longer fit the visual grammar of life on Earth as most people know it. A plateau covered in umbrella-shaped trees that drink fog and bleed red, surrounded by bottle trees growing from rock faces at improbable angles, in an island that has been separated from the rest of life for 20 million years. It is, by all reasonable measures, the most alien-looking inhabited place on Earth. In the Waikato region of New Zealand's North Island, in a ridge of limestone formed when this area of the Pacific was submerged beneath a shallow sea approximately 30 million years ago, there is a cave. The cave system at Waitomo extends through 300 known chambers and tunnels, formed by slightly acidic groundwater dissolving the limestone over millions of years. Stalactites hang from ceilings. Underground rivers run through lower chambers. It is, taken purely as a limestone cave system, a fine example of the genre. What makes Waitomo unlike any other cave on Earth is not the limestone. It is what lives on the ceiling. Arachnocampa luminosa, the name means approximately shining spiderworm in Greek and Latin, is a species found only in New Zealand and parts of Australia. It is not a worm. It is not a spider. It is the larval stage of a fungus gnat, an insect that in its adult form looks like a small mosquito. The adult is unremarkable. The larva is one of the most extraordinary organisms on the planet. The larva hatches on the ceiling of a cave or sheltered bank, somewhere dark, somewhere humid, somewhere with still air. It begins glowing immediately upon hatching. The bioluminescence is produced through a chemical reaction between an enzyme called luciferase and oxygen, generating light at a wavelength of approximately 487 nanometers, a blue-green that is highly visible in complete darkness, The energy efficiency of this reaction is extraordinary. 90% of the energy used in the reaction is converted to light compared to the latest LED light bulbs, which convert only 20% of their energy to light. The glowworm is, from an energy perspective, 5 times more efficient than the most efficient artificial lighting technology currently available. The light is not decorative, it is a trap. From the ceiling of its cave, the lava suspends from its body a series of silk threads. Each lava spins up to 70 of them, each thread up to 70 centimeters long, coated along their length with sticky mucus droplets spaced at regular intervals. These threads hang down into the cave air like a beaded curtain, or from below like a constellation of silk threads backlit by the blue glow above. Insects that enter the cave, or that are born in the underground stream that runs through the lower chambers, are attracted to the glow above them, in the same way that insects in the open air are attracted to light sources on a dark night. They fly toward the ceiling, they hit the threads, they stick. The lava, sensing the vibration, pulls the thread up and eats what it has caught. The intensity of the glow varies. The larvae glow more brightly when they are hungry. A well-fed larva glows at reduced intensity. A starving one burns at full brightness. The trap is calibrated to metabolic need. When the prey is abundant, the advertisement can be subtle. When the prey is scarce, the light goes up. The larval stage lasts approximately 9 months. During this time, the larva grows from less than 2 millimeters to an inch or more, hangs from its cave ceiling, spins threads, catches insects, and glows. Then it pupates. The pupal stage lasts approximately 2 weeks, and then it emerges as an adult fungus gnat. The adult has no functional mouth. It lives only a few days, just long enough to mate and lay eggs. The larva that shines for 9 months, and the adult that lives for 2 or 3 days to reproduce and then dies. In the glowworm grotto at Waitomo, the lowest chamber of the cave where the underground stream runs through, the ceiling is covered with thousands of these larvae simultaneously. The tour that takes visitors through this chamber travels by boat on the water, with the guide pulling the vessel along a rope in total silence. No torches, no speaking. Loud noise or bright light causes the larvae to dim their glow, a defense response to potential disturbance. So the boat moves in silence and darkness, and the passengers look up. The ceiling above them is covered in blue-green points of light, not a few dozen, not a few hundred, thousands. Each one the glow of a single larva, suspended above its silk threads in the dark. The effect is described consistently and by everyone who experiences it as floating through a night sky. The Maori name for these creatures is titiwai, which means approximately the reflection of stars over water. The name predates any scientific understanding of what the organism is or how the bioluminescence works. It was given by people who entered the cave and looked up and found the only frame of reference available, the night sky. In northwestern Venezuela, at the point where the Catatumbo River flows into Lake Maracaibo, the largest lake in South America, something has been happening every night for as long as anyone can document, and almost certainly for much longer. Shortly after sunset, the sky above the mouth of the river and the southwestern edge of the lake begins to flash, and it does not stop. Catatumbo lightning occurs for 140 to 160 nights a year, 9 hours per day, with lightning flashes from 16 to 40 times per minute. The phenomenon sees the highest density of lightning in the world at 250 per square kilometre. That translates to over 1.2 million lightning bolts annually, concentrated in one specific location. No other place on Earth receives this much lightning. The Guinness Book of Records has formally recognized Lake Maracaibo as the lightning capital of the world. The cause is geological and atmospheric, and specific to this location. Lake Maracaibo is enclosed on three sides by mountain ridges, with its northern shore opening into the Gulf of Venezuela. The Caribbean Sea provides a constant supply of warm, moist air that flows into the lake basin from the north. The hot tropical sun draws additional moisture upward from the lake's surface throughout the day. And at sunset, as the land begins to cool and the temperature differential between the lake surface and the surrounding air increases, the warm, moist air mass rises and destabilizes. It collides with cool air descending from the Andes along the mountain ridges that form the western and southern walls of the basin. The result is cumulonimbus clouds of exceptional intensity, forming in the same location at approximately the same time, night after night. The lightning that results is mostly intra-cloud. The bolts occur within and between clouds rather than striking the ground. This makes the display visually spectacular rather than locally dangerous in the conventional sense of a ground-strike lightning storm. The flashes are visible from 400 kilometers away on a clear night. It can be so continuous that it temporarily turns night into day. For centuries, it served as a navigational beacon, the Maracaibo Beacon, visible from the open Caribbean on a clear night, telling sailors where the Venezuelan coast was, where the entrance to the lake was, as reliably as any lighthouse, a natural phenomenon that no one designed and no one controls, operating on geological and atmospheric logic that has nothing to do with human history, altered the outcome of a specific military operation in the age of exploration by making darkness unavailable. The storm also played a role in the Venezuelan War of Independence. In 1823, the Battle of Lake Maracaibo, a naval engagement in which Venezuelan Republican forces defeated a Spanish fleet, was aided by the lightning, which illuminated the Spanish positions and gave the Republican commander tactical information he would not otherwise have had. The everlasting storm has fought on both sides over the centuries, simply by being what it is: the most reliable, most intense, most enduring lightning phenomenon on Earth. Along the southwestern coast of Africa, running for more than 2,000 kilometers through Namibia, Angola, and the northwestern edge of South Africa, there is a desert that is older than almost everything else on this list. The Namib is not old in the way that mountains are old, or the way that ancient cities are old. Having endured arid or semi-arid conditions for roughly 55 to 80 million years, the Namib may be the oldest desert in the world. When the Namib began forming, the dinosaurs had been extinct for only 10 to 25 million years. The Himalayas did not yet exist in any form. Europe was an archipelago. The Atlantic Ocean was significantly narrower. The Namib has been dry since before the world looked anything like the world that exists today. The cause of this extreme age and extreme aridity is the Benguela Current, a flow of cold water moving northward along the southwestern African coast from the Southern Ocean. Cold water does not evaporate readily. When warm, moist air from the Atlantic moves toward the coast and passes over the Benguela Current, it is chilled, and cold air holds less moisture than warm air, and so the moisture precipitates before it reaches the land. The Namibe's aridity is caused by the descent of dry air of the Hadley Cell, cooled by the cold Benguela Current along the coast. The result is a desert directly adjacent to the ocean, one of the most unusual geographical configurations on Earth. A place where you can stand with the Atlantic behind you and the driest conditions on the continent in front of you. In the most arid portions of the western Namib, annual rainfall averages 2 millimeters. A single heavy dew delivers more water than the Namib receives as rain in an entire year. And yet, the Namib is alive. Not despite its aridity, but in a very specific sense, because of the system that creates it. Because the Benguela Current that prevents rain from reaching the land also creates fog. The cold water cools the marine air layer, and the result is dense fog that rolls off the ocean in the early morning hours and pushes inland. The fog can penetrate up to 100 kilometers from the coast. And in the Namib, fog is not incidental weather, it is the water supply. The desert darkling beetle, Onimacris unguicularis, has evolved one of the most elegant solutions to the water problem in the natural world. Each morning, as the fog rolls in, the beetle climbs to the crest of a sand dune and tilts its body at a specific angle. Head down, abdomen elevated, pointing into the oncoming fog. Its back is covered in a pattern of hydrophilic bumps surrounded by hydrophobic grooves. The fog particles hit the bumps and adhere. The droplets grow. When they reach sufficient size, the hydrophobic grooves channel them toward the beetle's mouth. The beetle drinks from the fog through a physical structure on its own back that took millions of years of evolution to produce. The Namib also holds a plant that has been called the most extraordinary plant on Earth. Welwitschia mirabilis grows only in the Namib and the immediately adjacent Karoo Desert. It produces exactly 2 leaves in its entire lifetime. The leaves split and fray in the desert wind, so that an old specimen appears to have many leaves, but there are only ever 2, extending from the central disc in a tattered sprawl. The largest known specimens are estimated to be more than 2,000 years old. Welwitschia is notable for its survival in the extremely arid Namib conditions, made possible by its ability to capture moisture from coastal sea fogs. A plant that began growing when the Roman Empire was at its height, still alive, still producing its 2 leaves, still absorbing fog moisture on a Namibian desert plain. The sand dunes of the Namib in the Sossusvlei region reach heights of 300 meters, among the tallest in the world. Their color is not the pale gold of most desert dunes. The sand of the Namib is rich in iron oxide, and the color it produces is a deep orange-red that intensifies toward the dune crests and deepens at dawn and dusk into something approaching copper. The dune, called Big Daddy, near Sossusvlei, rises 325 meters from the flat pan below it. At its crest, the ridge is knife-sharp, a line between the slip face in shadow and the windward slope in full light, the boundary between orange and cream shifting slightly with every wind. The dead trees in Deadvlei below, ancient camel thorns that have been dead for approximately 900 years, preserved by the extreme aridity in a state of desiccated perfection, stand in the white clay pan below the dunes in a configuration that is so visually extreme. And then there are the circles. Fairy circles are barren patches of land surrounded by grass, typically found in the desert's sand dunes and plains. Their perfectly circular formation, visible from the air, ranges from 1.5 meters to a staggering 25 meters in diameter in some regions. These circles appear across hundreds of kilometers of the Namib, spaced with a regularity that is itself part of what makes them strange. Not clustered, not random, but evenly distributed across the landscape as if placed there according to a rule. From the air, a section of the Namib, dotted with fairy circles, looks like a surface with a regular pattern of holes punched through it. The grass grows at the margin of each circle, but not inside it. The circles never overlap. They maintain their spacing. The cause has been debated for decades. The leading theories involve sand termites, which are found inside every circle examined, clearing vegetation and harvesting the water that percolates into the bare soil beneath, effectively farming their own water supply by removing the plant competition that would otherwise extract it. A competing theory proposes that the plants themselves, competing for scarce water in the arid soil, produce the pattern through a self-organizing process that naturally generates regular spacing. Both theories have evidence. Neither has been accepted as definitively correct. The circles have been known to scientists since the 1920s, and the debate about their origin continues as of today. To date, there remains no universally accepted theory as to the source of these curious patterns. The Himba people, the indigenous semi-nomadic pastoralists who have lived in the Caucoveld region of Namibia for centuries, have their own answer. The circles are footprints of their god, Mukuru. The god walked across the desert, and where he stepped, the ground became bare. The circles are the evidence of a presence. What connects all 5 of these places, the Mirror Flat in Bolivia, the alien island in the Arabian Sea, the glowing cave in New Zealand, the everlasting storm in Venezuela, the ancient desert in Namibia, is not that they are unusual. Unusual things are everywhere. What connects them is that each one is the endpoint of a long, specific, coherent process that has been running for long enough to produce something that exceeds ordinary expectations entirely. The Salar de Uyuni is what happens when a prehistoric lake dries over thousands of years and leaves behind the largest salt deposit in the world. Socotra is what happens when a landmass is isolated for 20 million years. Waitomo is what happens when a species evolves in a cave for long enough to perfect bioluminescence as a hunting strategy. Catatumbo is what happens when a specific geography and a specific atmospheric dynamic produce a feedback loop that has never stopped. The Namib is what happens when a cold ocean current and continental positioning combine to create aridity for 55 million years. Each of them is completely logical. Each of them, nevertheless, looks impossible. And they are all real. They are all there right now. The salt flat is reflecting the sky. The trees are drinking fog. The larvae are glowing in the cave ceiling. The lightning is flashing over the lake. The beetle is tilting into the morning fog on a dune crest that has been there since before the Ice Age. Tell me in the comments which of these 5 places you would go to first, and why. I read every single comment. And tell me where in the world you're watching from. That information matters to me more than you might expect. Shadow Atlas will keep finding these places. The Earth is stranger than anyone has had time to fully document. Thank you for watching. There is a detail about the Salar de Uyuni that deserves more space than it usually gets in discussions of the place. The island of cacti at the center, Isla Incahuasi, is not simply a visual curiosity, although it is visually extraordinary. It is a stratigraphic record of the Salar's own history. The island was an underwater seamount in the prehistoric lakes that preceded the salt flat. As the lakes evaporated over thousands of years, the water level dropped and the summit of the seamount emerged above the surface. The cacti that grow on it have been growing since before the salt flat was the salt flat in its current form. They are older than the mirror, older than the hexagonal crust, older than the lithium economy that the world is now building in this direction. The cacti on Isla Incahuasi grow at a rate of approximately 1 centimeter per year. A 10-meter specimen has been growing for approximately 1,000 years. The oldest specimens on the island were established in the early medieval period, when the Norse were settling Iceland and the Abbasid Caliphate was at the height of its cultural influence. They have been growing on this island in the middle of the Bolivian Altiplano for the entire subsequent history of the world, as most people understand it. The entire period of European expansion, the entire Industrial Revolution, both world wars, the space race, the digital revolution. The cactus on the island does not know about any of this. It grew at 1 centimeter per year through all of it. The lithium dimension of the Salar deserves direct attention because it is not separate from the natural wonder. The lithium is inside the natural wonder. It is dissolved in the brine that saturates the substrate beneath the mirror surface, beneath the hexagonal crust, beneath the island and the flamingos and the 1,200-year-old cacti. It is there because the prehistoric lakes that created the Salar dissolved it from the surrounding rock over thousands of years and concentrated it as they evaporated, and the geological configuration of the Altiplano kept it there rather than allowing it to drain to the ocean. The same geological history that produced the world's most extraordinary flat surface also produced the world's largest concentration of the element that the 21st century has decided it needs most. Bolivia has deliberately and so far successfully resisted large-scale foreign extraction of this lithium. The politics of this resistance are complex. They involve national sovereignty, the memory of colonial resource extraction, the question of who benefits from the transformation of a natural wonder into an industrial supply chain, and the practical reality that extracting lithium from the Salar's high magnesium brine is technically more difficult than extracting it from other deposits. The mirror flat is not protected by law in the same comprehensive way that national parks are protected. Its protection comes partly from its own geology and partly from the Bolivian government's decision about what the Salar is for. That decision is still being made. The specific mechanism by which the dragon blood tree's canopy collects water is worth understanding in more detail, because it is one of the more sophisticated evolutionary solutions to the water problem in the plant kingdom. The leaves of Dracaena cinnabari grow only at the outermost tips of the youngest branches, a characteristic of the monocot family to which it belongs. They are stiff and narrow and arranged densely so that the outer surface of the canopy is essentially a continuous mat of leaf surface area facing upward. When fog rolls across the Dixam Plateau, fog particles, water droplets so small they remain suspended in air, contact the surface of the leaves and adhere. The leaf surface cannot absorb water directly, but the droplets accumulate, merge, grow larger, and when they reach sufficient mass, they fall from the leaf surface to the ground below the tree. The tree's root system, which extends outward under the shade of the canopy, absorbs this water from the soil. The shade provided by the canopy also reduces evaporation from the soil surface, so the water the tree intercepts from fog is conserved rather than immediately lost. The result is that a dragon blood tree is, in a functional sense, a fog-harvesting structure that feeds itself and creates a microhabitat beneath its canopy that supports a wider community of organisms. The shade beneath the canopy is significantly cooler than the exposed plateau surface. The soil beneath it holds more moisture. Other plants grow there that could not survive in the open. The tree is not just an organism. It is a piece of local infrastructure, a microenvironment, a piece of architecture that the plateau's ecology has built over millions of years to manage the water that falls as fog rather than rain. When Socotra's dragon blood trees die, the microhabitat they sustained dies with them. The biodiversity that sheltered beneath their canopies disperses or disappears. This is why the tree's decline is not simply an aesthetic loss. It is an ecological cascade. The storms that have been uprooting ancient specimens, the goats that have been eating the seedlings that would replace them, the warming and drying of the Yemeni climate. All of these forces are attacking not just a tree species, but the entire ecological structure that the species has been building and maintaining for millions of years on an island where nothing else serves the same function. The adult fungus gnat that emerges from the Waitomo cave ceiling has no mouth. This is worth lingering on because it is such a complete inversion of normal expectations about an organism's life that it reads as an error the first time you encounter it. Adults of most insect species that undergo complete metamorphosis, that is, species that have larval, pupal, and adult stages, have adult forms that can at least drink, if not eat. The adult Arachnocampa luminosa has essentially no functional gastrointestinal system whatsoever. The resources it has available to it are those it accumulated as a larva. Its entire adult existence, the emergence from the pupa, the dispersal through the cave in search of a mate, the mating, the egg-laying must be accomplished on the energy the larva stored over 9 months of hunting from its silk threads on the cave ceiling. Every glowing organism on the ceiling of Waitomo's glowworm grotto represents this entire life cycle compressed into a single point of blue-green light. The 9 months of the larva, the 2 weeks of the pupa, the 2 days of the adult that cannot eat. All of it the context for the light you are looking at from the boat in the darkness. The cave ceiling at Waitomo is the end point of one of those independent evolutionary origins, maintained over millions of years in the dark, damp limestone caves of a specific corner of New Zealand's North Island. The scale of Katatumbo's lightning production demands more context. 1.2 million lightning bolts per year means approximately 3,300 per day. On peak October nights, with up to 280 bolts per hour in a 9-hour window, the rate can approach 2,500 bolts in a single night. Each individual bolt releases the energy equivalent to approximately 1 billion joules, enough to power a 100-watt light bulb for roughly 320 years. At 250 bolts per square kilometre per year, the Catatumbo River mouth region receives more electrical energy from lightning than any equivalent area of the Earth's surface. NASA satellite data confirms these figures. The ozone production from this volume of lightning is also remarkable. Lightning converts atmospheric nitrogen and oxygen into nitrogen oxides, which react with other compounds to produce ozone. The Catatumbo storm is thought to produce a significant contribution to the local ozone layer, though the extent of this contribution and its global significance is still a topic of active scientific debate. The Catatumbo lightning has been proposed as one of the phenomena that may help explain why the tropical Atlantic atmosphere around Venezuela has a relatively elevated ozone concentration compared to expectations. A lightning storm that alters atmospheric chemistry at regional scale. This is the scale at which the everlasting storm operates. The Namibe's welwitschia has a quality worth spending more time with. The plant's 2 leaves do not fall and regrow in any seasonal cycle. They extend from the central disc continuously, growing from the base, dying at the tips, the living portion of the leaf advancing along a channel that feeds from the disc outward. The tips of old specimens are tattered and shredded by the desert wind, split into ribbons, sometimes curled and twisted into complex shapes by decades of weathering. But the growing base is still there, still producing, still connected to the disc that has been alive for 2,000 years. A cross-section of the disc in a large specimen shows growth rings, like a tree, but the rings are not annual, because in the Namib annual means almost nothing. The rings reflect growth pulses tied to periods of relative moisture, which in the Namib come years apart. Reading the growth history of a welwitschia is reading a history of the fog and the rare rains and the long dry intervals that the Namib has been cycling through for millennia. The Namib's fog-adapted organisms represent a broader truth about biological creativity. In the absence of one form of water input, rainfall, evolution found another route to the same resource. The fog beetles, the welwitschia, the dragon blood tree on Socotra, the glowworm in its cave, each one represents a biological system that, confronted with a constraint that would appear to rule out life, found the constraint to be a design parameter rather than a deal-breaker. The desert has no rain, but it has fog. The cave has no sunlight, but it has insects that fly toward light. The isolated island has no mainland gene flow, but it has 20 million years. The Earth, it turns out, has a very high tolerance for the apparently impossible. One more dimension of Socotra that does not get enough attention: the language. The people of Socotra speak Socotri, an ancient South Semitic language that predates Arabic in the region, spoken nowhere else in the world. It has no traditional written form. It survived for thousands of years as a purely oral language, passed from speaker to speaker across generations on an island that the outside world could only reach for a few months of the year because of the monsoon. The isolation that preserved the dragon blood tree preserved the language of the people who named it. The cucumber tree and the bottle tree and the frankincense of Socotra exist only here. The word for dragon blood in Socotri also exists only here. The island is a biological and linguistic archive simultaneously, the product of the same isolation. Socotri belongs to the same family of ancient South Arabian languages as the languages spoken in southern Arabia before Arabic became dominant, languages that Arabic largely displaced from the peninsula over the past 2 millennia. On Socotra, cut off from the mainland for most of the year, the displacement did not happen. The island's isolation preserved a linguistic fossil in the same way it preserved a biological one. The tension between the Salar de Uyuni's identity as a natural wonder and its identity as the world's largest lithium deposit is not going away. As electric vehicles become cheaper and more widely adopted, and as the global demand for battery-grade lithium grows, the pressure on Bolivia to extract what is under the mirror will only increase. The Bolivian government has consistently maintained that extraction must be done on national terms, under national control, with benefits flowing to Bolivians rather than to foreign shareholders. Whether that position can be maintained as the economics intensify is a genuinely open question. The mirror might be a mirror for another 50 years. It might also be an industrial site. The dragon blood trees of Socotra are dying faster than they are reproducing. The forests surveyed by conservation researchers are described as over-mature, full of old, large specimens, empty of young ones. The regeneration blocked by the invasive goats that arrived with human commerce and ate every seedling before it could establish. Some of the old trees survive where the terrain is too steep or too rocky for goats to access. On the accessible plateau, there is an aging population of trees with no successors. The conservation work being done by local families, small nurseries, wire enclosures to keep goats out, saplings watered by hand, is the right kind of response, but the scale is inadequate to the problem. The island is not prioritized for conservation funding because the country it belongs to is in the middle of a civil war. Catatumbo's lightning has been used, proposed, discussed, and occasionally studied as a potential energy source. The technical challenges of harvesting lightning, capturing the energy of a bolt that lasts milliseconds and travels an unpredictable path, have so far proven insurmountable at any practical scale. But the theoretical energy available at Lake Maracaibo is staggering. 10 minutes of Catatumbo lightning is enough to illuminate all of South America. The storm does not know it has this value. It continues because the Caribbean keeps providing warm water and the Andes keep deflecting the winds and the lake keeps evaporating in the tropical heat. The conditions are structural. The storm is the result. The Namibe's fairy circles are, as of this writing, still unexplained to scientific consensus. The termite theory has good evidence behind it, and many researchers who support it. The plant self-organization theory also has good evidence, and many researchers who support it. The two may not be mutually exclusive. Termites may be involved in some circles, plant dynamics in others, or both mechanisms may operate simultaneously in the same landscape. What is certain is that the circles have been there for as long as anyone has observed the Namib from the air, that they cover hundreds of kilometers of desert without overlapping, and that the desert landscape cannot produce them anywhere else. They have been found only in Namibia and in a specific part of Western Australia, which has different soil composition and may or may not be produced by the same mechanism. The Himba footprint of God explanation contains something that the scientific debate currently cannot, a settled answer. These are the places where the Earth has gone furthest from expectation. Not because they are extreme in temperature or altitude or danger, although some of them are those things too, but because they each represent a long, specific, coherent process that has produced at its endpoint something that should not exist. The Mirror Flat in Bolivia, the alien island in the Arabian Sea, the Constellation Cave in New Zealand, the everlasting storm in Venezuela, the ancient desert that drinks fog. They are all there, right now, doing what they do. See them while they are still there to see.